Hello, I'm Liam, team captain of 7405 Kinetic, and today I'll be introducing to you our team's codebase. The most important part of our code is odometry, or the use of sensors to estimate a robot's position on a coordinate plane. We use 3 shaft encoders arranged in this formation that return rotations of unpowered dead wheels to approximate distance traveled, as well as a single inertial measurement unit that tells us our robot's heading on the coordinate plane. Using encoder values in our IMU heading, we can use trigonometry to solve for our x and y position at all times as illustrated. However, a holonomic drive like ours, or one that can strafe like so, has the additional capability of spin strafing, or turning while maintaining a constant net movement in one direction. The problem arises that turning causes our dead wheels to rotate even though it doesn't correspond to net movement on the coordinate plane. This is solved by eliminating rotations associated with turning from our dead wheel readings. Using information about each encoder's offset from our robot's center of rotation as well as our IMU heading, we calculate how much our dead wheels would have rotated if our robot turned in place to the observed IMU heading. Subtracting these values from the observed encoder values gives us rotations associated exclusively with net movement in the XY coordinate plane. Through the use of a programming technique known as threading, we make it so our robot is constantly performing this calculation under other simultaneous processes, giving us real-time positioning data. An important application of our odometry code takes place in the move-to function, which uses information about our current position and PD control to allow us to move to any point on the field with ease. But what exactly is PD control? PD control solves the problem that due to momentum, robots stopping too suddenly often overshoot a target position. It accomplishes this through an induced slowdown of our robot to give us greater control over our stops, by iteratively setting our speed equal to the sum of the error between our current position and a target, as well as the derivative of our error over time. Both of these terms have a slowing effect on our robot. As we get closer to our target, error decreases, and since error decreases every iteration, the derivative of error is always a negative number. This provides a deceleration curve that approaches 0 as we get closer to the target. The finished product looks something like this. Our move-to function works well with simple movements, but can become burdensome when we want to perform complex maneuvers composed of many independent movements, as each movement requires its own PD-guided slowdown. Luckily, our implementation of an algorithm known as peer pursuit allows us to generate one continuous path between multiple points, increasing efficiency and consistency. Our algorithm begins by generating a direct path between the waypoints, or the points that we want our bot to pass by. Next, we envision an imaginary circle around our robot's current position, given by the red dot. The intersection between this circle and the generated path, denoted by the blue circle, is fed into the base move-to function, and as our bot pursues this point, its current position updates and a new target point is fed into the move-to function. By pursuing points ahead of its current position on the waypoint path, our bot is able to anticipate changes in direction and execute smooth turns like so. Lastly, we implement a ball storing system that automatically indexes balls into preset stored positions for increased efficiency and consistency during autonomous runs. Using ultrasonic sensors to detect proximity, as well as limit switches which have a pressed and unpressed state, we are able to detect whether a ball is in one of 3 locations and adjust motor power for our scoring and intake mechanisms accordingly. Using these 4 tools of odometry, PD control, peer pursuit, and storing, we are able to create an effective skills path.
Feeling like I'm drowning in these other fish. See me going round, I'm like a mother shit. Encounters of the third kind now. Not yours, not mine. Hot damn, this some other shit. Not landing like a lover's wish. Getting thrown in a big old well. Cause there ain't no end to the fall for the other till you hit that shit that they just don't tell. Oh well, see. Some will they missing and some will hit. Some will just kiss for the fun of it. And then there's a slip of the tongue asking what will become when it's all said and done. And when Sunday hits, can we just keep the summer lit like the sun in the day? You want a moment of truth, but a moment is youth. And like moments, they all run away. I'm saying that.